Hi all, I am here with my new video on chapter Energy and Chemical Reactions. Let's start. In this video we are going to learn about Gibbs free energy and standard heat of formation. Gibbs free energy. All spontaneous reactions are able to contribute a portion of their energy to perform useful work. The portion of energy that is available to perform work is known as Gibbs free energy and it is symbolized by capital G. As a spontaneous reaction proceeds, its ability to do more work decreases and after a time the system can't convert any energy to perform work and the reaction stops to be spontaneous. Then it is said that system is in equilibrium. Example, batteries. We can predict whether a reaction will be spontaneous or not under a given set of conditions with the help of the Gibbs free energy change. The Gibbs free energy change is defined as follows: del G equal to del H plus T del S. Del G takes both del H and del S into account, but the absolute temperature plays an important part and is associated with the disorder. As temperature rises, the disorder factor becomes important. When the equation del G equal to del H plus T del S is applied, negative del G value indicates that the reaction is spontaneous and positive del G indicates that the reaction is not spontaneous. Prediction of reactions according to algebraic signs of variables. We can predict that a reaction is spontaneous or not, which is related to the algebraic signs of variables. A table is following. Reaction A, where del H is negative, del S is positive, del G is negative, results spontaneous at all temperatures. Example, 2 mole of NO2 which is in gas state convert into 2N2 gas plus oxygen gas. Reaction B, where del H is negative, del S is negative, del G is question mark, results spontaneous at low temperatures. Example, H2O liquid converts into H2O solid. Reaction C, where del H is positive, del S is positive, del G not known, spontaneous at high temperatures. Example, 2 mole of ammonia in gas state convert into N2 in gas state plus 3 mole of H2 gas. Reaction D, where del H is positive, del S is negative and del G is positive. Reaction is not spontaneous at all temperatures. Example, 3 mole of oxygen in gas state convert into 2 mole of ozone in gas state. Swiss chemist GH has found that when two or more chemical reactions are combined, the heat of reaction is simply the sum of the individual heat of reaction. For example, nitrogen reacts with oxygen and convert into 2 mole of nitrogen oxide. Del H1 is 180 kilojoule. When this nitrogen oxide reacts with oxygen and convert into nitrogen dioxide, del H2 is equal to minus 112 kilojoule. The net reaction is N2 plus 2O2 is equal to 2NO2. Del H reaction is equal to del H1 plus del H2 equal to 180 kilojoule minus 112 kilojoule equal to 68 kilojoule. Nitrogen oxide does not appear in the combined reaction because it was present in equal amount on opposite sides of the individual reaction. Hess's law is the application of the first law of thermodynamics, which is a statement of conservation of energy. Standard heat of formation of a compound. The standard heat of formation is defined as the heat absorbed or released when 1 mole of a compound is formed from its elements under standard condition. Its symbol is del HF 0, where the subscript F is for the word formation. The elements that form the compound are in stable state. The heat of formation for elements in stable state is assigned a value of 0. Heat of reaction from standard heat of formation. We can use the standard heat of formation of individual substance to calculate the standard enthalpy change of a reaction involving these substances. It is represented by this following equation. The sigma symbol means the sum of, and that you add the individual values of the products and reactants separately before you subtract. Symbol N and M represent the coefficient associated with all the substances in the reaction.